Welcome to the Explainer. Today, we're going to chart a course through Python, which is, one of the world's most popular and powerful programming languages. If you've ever wanted to learn to code, well, consider this your roadmap from zero to absolute hero, step by step.
Okay, so you've decided you want to learn Python. That's awesome. But where do you even begin, right? The journey from a totally blank screen to building really powerful applications can seem kind of winding and honestly a little confusing. But don't worry, we're here to give you the map.
All right, before we even touch a keyboard, we have to get our heads around this one core philosophy. This quote? It's our first big landmark. See, Python is designed from the ground up to be readable and just straightforward. This focus on making life easier for the developer and making software better is really what makes it so powerful.
Okay, let's kick things off right at the starting line. What in the world is Python? And probably more important, what can you actually do with it?
The short answer is pretty much anything. Python is what we call a general-purpose language, which basically means its uses are virtually unlimited. From automating simple little tasks on your computer to powering massive websites, from analyzing huge data sets to controlling robots and even spacecraft, Python is the super versatile tool that can make it all happen.
All right, let's get our hands dirty and take that very first step. In the world of programming, that means understanding the absolute basics of how to run your very first piece of code. And you know what? The process is way simpler than you might think. You just write your instructions in a plain old text file, usually with a .py at the end. Then you open up your computer's command line, which is just a text-based way to talk to your computer, and you tell the Python interpreter to read your file and do what it says. And that's it. Bam! You've just run your first program.
Now, this next part is one of those things that makes Python feel a little bit like magic. It's called dynamic typing. See, in a lot of other languages, you have to tell the computer ahead of time what kind of data a variable is going to hold. But in Python, the types live with the data, not the variable names. A variable is just a label. This means a label like X can point to a number one second and a piece of text the next. This kind of flexibility is a huge reason why Python is so fast for developing new ideas.
So to actually store your data, you're going to lean on these fundamental building blocks. You'll use strings for any kind of text, lists for ordered collections of things, and dictionaries to store stuff by a key, kind of like a real-world dictionary. And notice that little mutable column? That just means you can change lists and dictionaries after you've made them. Super handy.
All right, up until now, our programs have been pretty straightforward. But at this stage of the journey, this is where they get smart. We're going to learn how to make them do more than just run a list of commands. We're about to give them the ability to think. Think about it. To solve any real-world problem, a program needs to be able to make choices and do tasks over and over again. This whole idea is called controlling the flow of execution, and it's really where your code starts to come alive. And this is where you really see that Python philosophy shine. You use if and else statements to make decisions. You use for and while loops to repeat things. But that last point, indentation, that's the secret sauce. Python doesn't use brackets or weird keywords to group code. It just uses whitespace. It means the way the code looks is the way the code runs. It kind of forces you to write clean, readable code. It's brilliant. Okay, so you've got the basics down. You can make your code do stuff. But what happens when your little script starts turning into a big, complex program? Well, you're going to face a new challenge, managing all that complexity. The name of the game here is don't repeat yourself. Just imagine you have the same bit of logic in 3 different places in your code. If you need to change it, you have to go find all 3 and change them. But if you put that code into a single function, you only have one copy to worry about. It makes things so much easier to manage.
And here's a perfect picture of what that means. Just look at the before on the left. We're copying and pasting that calculation. It works, sure, but it's messy. Now look at the right. We've packaged that logic into one reusable block called GiveRaise. The result? The code is cleaner, way more organized, and just a whole lot easier to work with.
So the next level up in organization is the module. And honestly, it's a beautifully simple idea. A module is just a file that contains your Python code. That's it. This is how you group related functions together, so you can build your own libraries and share tools across all your different programs. All right, take a deep breath. We are now reaching the conceptual peak of our journey. This is the part that truly elevates you from just a coder to a software architect.
Object-Oriented Programming, or OOP. So what on earth is OOP? Well, think of it as a way of modeling the world by creating objects that bundle together data, we call those attributes, and the actions you can perform on that data, which we call methods. The real power here is code reuse. OOP lets you build on what already exists instead of starting from scratch every single time. And this slide just lays out the process perfectly. First, you define a blueprint or a class, like a general concept of a person. Second, you create real individual objects from that blueprint, like our instance, Bob. And third, and this is the really cool part, you can create a new specialized class, like a manager, that inherits all the stuff from person but adds its own unique skills. So the big takeaway, the whole point of this, is that you are building on top of existing tested code instead of changing it or rewriting it. This is exactly how massive, complex systems are built efficiently and reliably. You're not just writing scripts anymore, you're actually designing systems. And you've made it. You're at the summit. You understand the core language, all the way from basic data types to object-oriented design. And from up here, you can see this vast, incredible landscape of possibilities that Python opens up for you. Because here's the thing, one of Python's most powerful features isn't just the language itself, it's the massive, thriving ecosystem of libraries that surrounds it. For almost any problem you can possibly imagine, chances are someone has already built a tool to help you solve it. You don't have to reinvent the wheel. I mean, whatever you want to do, there's almost certainly a powerful, free, open-source tool for it. Want to do heavy-duty numeric programming? You've got NumPy. Build a website? Check out Django or Flask. Dive into data science or machine learning? Pandas and TensorFlow have your back. The journey of mastering Python is really about learning how to use all these amazing tools. So, there you have it. That's the roadmap. From that basic philosophy of simplicity, all the way through data types, control flow, functions, and object-oriented design. Mastering any skill is a lifelong journey, of course. But with this map, you now have the landmarks to guide you from your very first line of code all the way to building complex, world-class applications. The only question left is, where will your journey take you?